everyone, welcome back to the channel. Today we are going to walk through jump game 1 using the greedy approach, and I'm going to explain it exactly how I wrote it in my own notes. This explanation is super visual, super intuitive, and trust me, once you understand this, you'll never forget jump game again. Let's get started. So this is Leetcode 55 jump game. We are given an array that is nums 23114. We write its index 0, 1, 2, 3, 4, and nums I tells us from index I how far can you jump. Like from index 0, we can jump to either 3 or we can jump to either 1. And the question is very simple. Can we reach the last index? We have to return true or false. Everything in this problem boils down to one insight. Keep track of the farthest index you can reach so far. We call this max reach. This is the single most important variable in the entire problem. If you understand this idea, the problems becomes trivial. Now, why do we need greedy? Because at every index, we choose the best possible for this approach. We never backtrack. If we get stuck, it is impossible to reach to the edge. So that's all greedy needs in this problem. Always keep the maximum reach updated. Now, why greedy works here? Let's take an example. Look at index 0. So our nums 0 is 2. So the maximum reach would be index plus the value on it, that is 2. Now the reachable zone becomes this, from index 0 to index 2. Now if I is greater than maximum reach, we cannot even stand on this index. So how we can jump from it? And if I is greater than max reach, we return false. Why? The greedy rule is if the current index I is inside this zone, we are safe. If I ever becomes greater than max reach, we cannot even stand here. So we fail. Because if I can't stand at index I, how will I jump from index I? To explain it more clearly, let's look at this spray example. This is the most important example. These single example that explain greedy better than the passing one. We initially start with max reach equal to 0. Let's walk index by index. Is 0? 0 is less than equal to max reach, that is 0. So max reach becomes a value that is at the index 0. That becomes 3. Right now, we can reach to the index 3. Next, I becomes 1. 1 is less than equal to the current max reach? True. But the max reach is the maximum of this value and this value. So max reach remains 3. Next, I becomes 2. 2 is less than equal to 3. Max reach remains 3. Now we come to I equals to 3. 3 is less than equal to 3. Max reach still remains 3. Now I equal to 4 is the critical moment. 4 is 4 less than equal to max reach? No. So this is the moment we fail. This 0 at index 3 forms a wall. We cannot jump past it. Maximum reach stops at 3, but the target is index 4. So reaching the end is impossible. This is exactly when greedy returns false. Now let's look at the Java code to the solution. We keep only one variable, that is max reach. Max reach is the farthest index we can reach so far. As we walk through the array from left to right, we simply check, can we stand on the current index? If yes, we update how far we can jump from here. If no, we can never reach this index, hence return false. That's the entire greedy idea. Let's break down the code line by line. So max reach equals to 0. At the start, the farthest index we can reach is 0 itself. This makes sense because we start at index 0. For index I, we walk the array from left to right. We are checking whether each index is reachable. If I greater than max reach, we return false. This is the most important line. This checks Is the current index I outside the area we can reach? If yes, we fail immediately. If max reach equals 3 and I equals 4, it means we cannot reach index 4, so we cannot stand here, so we cannot jump from here, so we can never reach the last index. Then the return falls immediately. In this line, max reach equals max dot max of max reach comma I plus num I means that if we can reach index I, we check index I, how far can I jump? I plus nums I is the farthest index reachable from position I. Then we update our global farthest reach. If this jump goes farther than previous list, update it. If it doesn't, keep the old value. In simple words, we try to extend your reach much possible when you are standing on the reachable index. If we finish scanning the entire array without failing, it means we never got stuck behind the wall. So we can reach the last index, hence we return true. To summarize, at every index we check if we can stand here. If yes, extend your reach, and if no, give over. The time complexity for this problem is O of n. Space complexity is O of 1 because only one scan is needed and only one variable. So it is super efficient. Now the one-line intuition for this problem is if we can reach index I try to jump as far as possible from it. If I reach a point where I cannot stand on, I leave. And that's it for today's session. We broke down Jump Game 1 using the 3D idea behind max reach and understood the failing example deeply. If you enjoyed this style, make sure to like, comment your next topic, and subscribe for more crisp DSA explanations. Thanks for watching. See you in the next video. Until then, bye.